All right, so now those who've seen my talks before know that I like to do interactive is kind of a leading word. I like to do talks that are different than just talking about slides. I like to have some practical demonstrations or interactive features of that sort of thing, because I find, especially when teaching security, that the best way to get the point across and help people to understand and learn is by actually allowing people to do the things themselves or see it being done rather than just hear about the theory. And so this talk, when I was coming up with the idea for it, I thought, why don't I just make the whole thing interactive? Can I make a talk that the audience can actually participate with while I'm doing the talk? And so that's what we're going to do today, is we're actually going to hack into a website together. So you want to go into your browsers, go to Lara.camp.evilhacker.dev, and we can get started in the challenges. So what we're going to do is break into this website. And so I have a bunch of different challenges that will teach you different aspects of security, different aspects of hacking, and different ways of thinking about how a hacker would try to break into your website, what they're going to do when they get to different stages in your site, different steps. And the idea being that by getting hands-on experience, by learning how a hacker would approach the problem, would approach breaking into a site, you can apply that when you're building your own sites. So when you're adding features into your application or you're making changes, well, you can be thinking about what would a hacker do at this point? How would they approach this? And how is this vulnerable? And are there things that you're accidentally putting in your application that are actually vulnerable? And just a quick disclaimer, because this is public, everyone can see the password attempts on my screen. Please be considerate of others. Don't put anything rude or offensive or anything like that up there. I really would not like to have to disable that feature and have to do it all manually myself. So just be respectful, everyone else, please. That'd be great. Cool. Okay, so where are we going to start? So the first step here is we're going to try and break into the sign-in form. And this is kind of the first step that you would do when you're breaking into a website. You would try and crack the password. Either you'd target a specific account or you would target any account. So you could use, say, a credential stuffing list, which is a list of known working usernames and passwords that you've stolen from some other website, from some other system. So you could use one of those lists and it gives you a list of usernames and passwords. You try this through, or you could do a brute force attack where you just try known passwords that people used before and see what happens. Because this is a demo and interactive, the nickname is your name. It's your email address. That's just for the leaderboard and for keeping things unique. The password is what you're trying to guess. And so if I put in a random password, I'm going to, of course, get an error. Now, the next thing that I'm supposed to demonstrate, which isn't going to work very well because we're all live at our own places, because this is an online talk, but when I'm running this talk in person at an event, most of the attendees will actually be using like the hotel, the conference Wi-Fi, which means that they're all going to have the same IP address, which quickly hits the rate limiter. And so the point I'm trying to make with this one is that rate limiters, if they're based on, say, IP address, can actually be easily bypassed, because the only thing rate limiting here is the IP address. And now we've got some people doing fast attempts, which is good, which means that we're hitting the rate limiter counter up. And those people are now blocked because they're running on the same IP address. And if I'm running this live in person with a room of, say, 700 people, well, that's a lot of people that are now getting blocked because they're all on the same IP address. But if you're a hacker and you hit this when you're trying to log into the website, all you need to do is rotate your IP address, which is actually really easy. You could just use a VPN. VPNs will give you many different IP addresses. You could just change IP and then try again. You could use a botnet. You could use Tor. There's a bunch of different methods you can use to actually get a different password. Sorry, not password, what am I saying? A different IP address, which would bypass the rate limiter. Now, rather than force all of us to use IP addresses, I'm just going to jump into my console and enable bot mode, which is just a fake way of, it just disables the rate limiter, but it's impersonating what would happen if you're actually rotating your IP address, because suddenly our password attempts disappears. It's no longer a thing because we're now running in bot mode. There's no more rate limiter, which means that we can try attempts as fast as we want, and we're still not actually going to hit that rate limit. And so the point I'm trying to make, as I said before, is that using an IP address or rate limiter isn't really a good idea. I mean, it works to a point, but it's really easy to bypass. And so rather than that, I would recommend using like the email address or the username as well, or instead of. And that way, if someone is trying to target a specific account and they're sending 10 different requests to attempt to log into an account with the same email address, even if they're running that over 10 different IP addresses, it's still going to hit the rate limiter because it's rate limiting based on the username or the email address rather than the IP address. So give it another try, see if we can get this password going. I didn't get it there, so we'll see what the password comes out as. You might notice, oh, there we go. Someone's found the password. What a lovely password we got there. So as a side note, I did actually cheat here. And the password that it says up here, oh, it's not letting me in. Is it hello for space, maybe? Oh, that's the user. Sorry. Go me. I'm not reading at all. It's not hello at all. It's 123 I built the talk and I still got it wrong. All right. So as you can probably figure out from that little momentary failure of mine, the password is actually randomly picked after I ran that last password of mine, which was the secret command, in order to delay everything. So that's there are a few tricks in this talk, but that's the big one. I just wanted to point out. So now people are getting in, which is fantastic. Okay. So we're a hacker. We're into the first stage. We've passed the first challenge. What's next? So we get access to this application. And we're looking at, what we can do. So when we get access to the application, say we've created a free account, what can we do now? What access do we have? How can we escalate our access, get more access to things? Well, we have a look around and see what's here. So the only real thing we can see here is that please verify your account and you don't have a premium account. And as you can see, our challenge is escalate our account to premium. So the only thing we have to interact with is the email. So this is what would be emailed to you when you created an account. It's just on screen to make this easier because this was designed to do through phones when I was doing live talks. So if we grab the verify URL and I click on it, it's going to verify our account, but we're still not premium. So we still didn't escalate our account. Can I get rid of this zoom? I've got a zoom toolbar up here that's hiding everything. Oh, I'm trying to ignore it. All right. Now, if we look at the verification URL that it's given us, we can see here that we actually have this bit in here. Premium equals 0. So this immediately jumps out at me as a potential vulnerability because this URL, which is being passed through the user's browser and their email client, has something that references premium, which is our objective. We want to escalate to premium. So what if we change that to 1? Invalid signature, of course, because the signature is verifying that the URL is correct. This is one of my favorite Laravel features, is the verified or the signed URLs feature, where it'll generate a URL and then tack a signature on the end, and then you can't change the URL because the signature will verify that it is as it should be. And I really love this feature. And this is stopping us from escalating to premium 1. But the question is, what if the signature isn't there? Well, it's still failing, but if I just get rid of signature entirely, we have now been escalated to premium. We've got through that setup. So what's going on here? So this one's based off a vulnerability that I found when I was doing a security audit for a client, where I noticed that they were generating a signed URL for email verification, but the code said, is there a signature? If so, validate the signature. If not, just let them in, because they were trying to have backwards compatibility. And so they decided they originally didn't have the signature at all, but they realized they needed to add it, but they didn't want to break the existing emails that had been sent out, because they could have any number of people that had a verify their account email in there, and then click on the link and it would be broken. So they decided for backwards compatibility, if it's an old link, if it's missing the signature parameter, then you don't validate the signature, assume that it's an old link. What they meant to do was go back in a few hours, a week later, and remove that backwards compatibility code. They didn't do that. They forgot to remove it, which meant that there was a vulnerability left in their code because they forgot to remove the backwards compatibility hack they added in there. And it was as simple as that. All you had to do was remove the signature completely from the URL and it let you straight in. Really simple to exploit when you figured it out. Really simple to fix too. They can just remove the code that added the check, but really, really easy to overlook. And I see that all the time when I'm doing my security audits, is that people will overlook really, really simple things like that. Or they'll make a change and they'll think, I'll come and fix it later. I'll do a backwards compatibility thing here now. when the new feature is rolled over, we'll remove it. They never remove it. And you're left with a massive vulnerability in your application because you forgot to actually follow up on a change that you made. All right, challenge number 3, let's move on. So in here we have edit user bio. Curious. All righty, so what we have to do here is edit the admin bio. Now, we can see here we've got edit user Steven. So this is my own bio and someone has given me something in here. Thank you very much for that. So I can write hello. But as our hacker, we're looking around, we're seeing what we can do, and we're editing our bio. But if we look at the URL, and I'm doing a lot of URL tricks because this was designed to work on the phone, and that's one of the few things that you can modify that isn't a direct field on the form on a phone. And we can see up here, we've got users 29 edit, which immediately jumps out at you as what's called an insecure direct object reference, or an IDOR. So we could change this number to 1 or 100 or any number, and we can see what happens. We could see if it lets us edit a different user. And if so, it means they're not authenticating the request properly, and that's a problem. So if I go to 1, we now have Lionel Gaiotti editing this person's bio, which is a big problem because we're editing someone else's bio. So as I said, they've forgotten to put authentication in here. Another really, really simple thing, and I see this all the time. Again, during my security audits, it is very, very, very common to find maybe one route out of 100 that is missing authorization. They've just forgotten it. Maybe they're running controller resource routing and middleware, and they've added in a custom action, and they've forgotten that the controller authorization for the resource routes doesn't actually grab the custom route. Or maybe they're using authorization inside their actions and they just forgot to put it in there. Or many other reasons. There are lots of reasons why, but it happens all the time. And I often find these, I mean, it's a bit painstaking, I've got to go through all different actions, but the point is that there's often just one route that's missing it, which is often a very important route that allows access to things. So now we're here on this edit user, but the challenge is edit the admin bio. And what we have to do to solve this problem is just kind of work our way through the IDs. If we go through from 1 to pick a number, eventually we will encounter the administrator. All we had to do is find the right number, which in this case is 13. So by changing the URL to user/13/edit, we're now on the user's bio. Hello. And now we can change whatever it says about the user. Really, really simple. Okay, so what do we do now? What happens at this point? Well, we're up to challenge number 4, because now we can modify the user's bio. We can get something running, potentially running in the user's browser. And if we can control something of the users, of the admin, I should say, if we control the admin's browser, if we can do something in the admin's browser, then we can potentially escalate our account, escalate our privileges, make some actual changes, some things that we were not supposed to do. So what we can do here is looking at the bio form, and we want to have a play around and see what we can do, what it supports. You know, so I can do, I don't know, hello world, not hell. Let's make this a bit nicer. Hello world. All right, so hello world there. Oh, I have a space. If I get rid of the space, you can never actually type when you're doing live talks. It's really annoying. All right, hello world in bold. So we now have Markdown being applied here. And the thing about Markdown being applied here means that what is processing the Markdown? And what you might not know about Markdown is that if they're using something that follows the common Markdown specification, it is actually vulnerable to cross-site scripting, because by default, it supports full HTML inline, which means that we can add some HTML. Alert, hello. Well, sort of, I kind of lied. All right, so we can see here that it's actually escaping this script alert. So we can't just throw a script tag in here directly. But this is because this form is actually using Laravel's Markdown, which uses Common Mark, and it's using the GitHub flavored variant of it. And that has some basic coding there to prevent you from adding in these sorts of tags. But this isn't the end of it. We could just stop here and move on and assume that it's not vulnerable, but that would be silly, because it is. because although script isn't allowed, we can put inline images. Inline source equals X, so a failed image on error equals, alrighty. Let's change these quotes around a bit. Oops. Hello. We are now running our code in the browser. All right. It's as simple as that. In standard Laravel's Markdown, that's Common Mark compliant, to get cross-site script running. And as I said, we're running this in the browser, but it's running on the admin's bio. So when the admin, if this admin views their bio, goes to edit their bio, or does anything else related to their bio, then it's going to run our cross-site scripting, our JavaScript here. And if we can run our JavaScript in the admin's browser, then we can make the admin's browser do whatever we want. And if we can make the admin browser do whatever we want, then we can escalate our account, because we can tell the application to escalate our account for us. So down here we have the talk helper, and this is just here to make life simple for us. What we want to do is send a post request in here. Now we could stuff around with fetch or HTML, XML, ref, whatever it is. I can't remember what it's called. We could stuff around with that, figure out the complicatedness, like someone in the log has just done there with fetch. There isn't actually an easy way, because we're running in Laravel. That's what Axios. We can actually use the tools that Laravel is providing, that the application gives us to use. We can use those tools directly. Axios.post is going to do a post request without having to stuff around with fetch and all its parameters and everything else like that. We can just make a post request right through there. The other benefit is Axios is going to inherit our CSRF token, which is something that using fetch or other more raw commands isn't going to grab, because they don't automatically pull the CSRF token from the cookie and where it's stored in order to make it. But if we can use Laravel's Axios, and which is already designed to pull in the CSRF token, and this does all the hard work for us. So I'm going to throw this in there. And as we can see, we've got this error. So we're getting closer. Axios is not defined. Now, Axios isn't defined because it's running immediately. So when the page loads, this runs instantly. And then the JavaScript payload, JavaScript include, is loaded later, which means that Axios doesn't exist yet. We can cheat. We can just tell it to wait. So I can do set timeout on that. Give it 100. I'm going to save update. Okay, so we're seeing a 403 error, so forbidden error. So the request is going through properly in our browser. But when it runs through in the admin frame, when it runs through in the admin's browser, it should actually escalate our account. And give me a sec, my admin frame seems to be having a minor issue. There we go. Yep, cool. All right, so as you can see here, we're now an admin, and so are these beautiful people as well. So if I refresh the page over here, you are now an admin. It was that simple. All we had to do to escalate our account to admin, to get admin privileges, was to run this, and was to get this code to run in the admin's browser. And this is the beauty of cross-site scripting, is that if you can get JavaScript running in your target's browser, in the admin's browser, in anyone's browser, you can make their browser do whatever you want. And as far as the application is concerned, as far as the server is concerned, as far as the browser is concerned, it's the user, the admin themselves, who's running that request, who's making that request. And so everything thinks that that request is a legitimate request from the administrator, and it's going to do it because everything looks legitimate. And that's how we escalate our account to administrator and take over control of applications. And that's why cross-site scripting is such a big deal. And it's one of these ones that pops up all the time, especially through Markdown and interactive fields like this, where you want to support Markdown and markup, or you can have a WYSIWYG editor, or other complicated things like that, or when you're doing your own custom parsing and adding in links and any of that sort of complexity that's doing more than just raw text and then displaying it raw, you have the potential for cross-site scripting, which has the potential for injecting scripts and doing malicious things. All right, so on to the last challenge. All right, so here we have a test page, a little info page, right? And as an administrator, no, I'm sorry, what am I saying? As a hacker, what we do is we look around, as I said before, and we poke on things and we see what we can find, see what we can do. And we can see up here in the URL, it says markdown/about. Now, this suggests to me that what comes after markdown is the name of a file or the name of a section or something that is a markdown thing. So if we change it to something else, say markdown/test, we can see how it interacts, how it reacts to that. Oops, bumped my mic, sorry about that. Hopefully that wasn't a loud thunk on your end. And so now we're on this page, we can see it says cannot find test.md. So it's confirmed for us that it's actually looking for a file called test.md on the server because we've typed test in here, which means that we can look for different files on the server through that path. Problem is, of course, we're after a .m file, not a m.md file, but we've still got progress because now we know where our vulnerable parameter is. So let's have a poke around and see what happens next. So we're going to change this to test.txt, and we can see instead that it's actually honoring the extension, which we can make the assumption that either the system is looking for .txt and honoring that, or it's looking for maybe a dot. And if it finds a dot, then it just honors the extension. So why don't we try this? Oops, env. 403 forbidden Nginx. So we've got this error because Nginx itself, the web server itself, has protection against accessing files that start with a dot. That's just pretty standard in most web configurations. So we need to bypass this protection and we need to get in because we're hacking into this site, right? Well, what we can do is we can encode the dot. If we can convince Nginx that we're not passing a dot, it'll let it through, and then the application itself will hopefully honor the dot. So we can use URL encoding, and we can grab the %2e here for the dot. So %2e is a URL encoded combination string for the dot. So we'll put that in there. All right, still fails because the browser knows what it is. It translates it for us, and it knows it's a safe character to go in. So we'll double encode it. So we'll encode the percentage. So %25 is percent, and the %2e is the dot. So we'll do %252e. Hopefully you're keeping up with this one. %25 gives us the % sign, and then 2e gives us the %2e for the dot. We send that, and now we have our dot env going through. We still have this pesky extension, but we're getting a lot closer. Now, it's worth taking a moment to consider where's the .m file. Is it going to be sitting in the directory where our markdown files are? No. So we're going to go back a level. So what we can do up here is I go ... like that. The web browser, again, is trying to be helpful. In this case, it's really not, and it's jumped us back to the markdown. So what we can do here, markdown. If I grab that, I can do the encoded dot. I can do enough, do the encoded dots, then that, and now we're looking for ... .m.md. Still got this, but we're traversing. What we can do if we want to get rid of that extension is we can actually change this to a normal dot, because the problem is the web server is grabbing the leading dot. So we can encode the leading dot, leave the second dot, and now we have ... .m. Which means it's not in this directory, maybe it's in the parent directory. So we'll go back another level. There we go. We now have access to the environment file for this application through this URL vulnerability. Because when they built this page, they weren't actually protecting it properly. They weren't considering people passing in unexpected values that would allow them to traverse levels to request different files. They just figured, it's a subdirectory, who cares, right? It's a URL parameter. Well, you can pass a lot in a URL parameter, especially when you can encode things like this, which makes it really easy to get to your environment file. All right. So what do they do wrong here? As I said, they're just trusting this input entirely. In this case, they're just trusting that, using that to direct towards the file. So what I recommend doing here instead is anytime you're loading files from the server, have the file names with a very specific character set. So say 0 to 9, A to Z, and only allow those characters. Don't allow slashes or dots or anything like that. And that way, when someone makes a request, you can validate the characters in the request are in the subset you allow. Because if your file name has to be 0 to 9, A to Z, then any request to anything else can be ignored entirely. And then no one can do any traversal because you can't traverse with just 0 to 98Z. You need something else. And if you remove the something else, you can't traverse. All right, so that's the end of the challenges, but I do have one more trick to show you because it's very common to hear and people say all the time that you need to protect your environment file and specifically protect your application encryption key. So the question is why? Why do you need to protect this key? Isn't everything that it is used for on the server? No. So if we look down here, we can see this site is actually running the session driver cookie. And for those who aren't aware of how session drivers work, is it tells it where to store the session information. And the cookie session driver stores it in an encrypted cookie. You're starting to join the dots? So I'll just pause LiveWire because it stuffs up this demo. We'll go into the application and cookies, and we can see up here, this one specifically with the funky name is the session cookie. So this is an encrypted session payload for this application. So I'll grab that. And then if I go over into my console, just jump out of here, drop bear, cookie forge, a little hacking tool I have. Good. Okay, so the original cookie values. This is the value I just grabbed from the cookie in my browser. Target URL, target user ID, sorry, that's the admin user we guessed before, which is 13. Encryption key, I will go back here, and it's this value here, which we have just obtained from the environment file. Jump in here, paste that in there, enter. And give that a moment. All right, so what we're doing here is it decrypting the cookie value. So this decrypts it using the encryption key that we've given it. Extract out the payload, turns it into an array and gets the session data. And we can see here, this is the session data. It's pretty boring, except for this line, which says this is the ID for the web authentication session, and the user ID is 29. We passed in 30, so what it's done, and you can see it here, login web request 13, it's actually changed the ID to 13, then it's encrypted the entire thing back up using the encryption key that we have, that we stole. Then we can go into the browser, I can get rid of that, put that in there, and refresh the page. We are now super admin, logged in as the admin, all because we stole the key. That is why you have to keep your admin key, your encryption key secure, because if someone can get it, they can decrypt things like your cookies. And if you're using cookie sessions or anything else in there, they can modify it and then control the application through it. Cool. Thank you very much for listening. I hope you enjoyed that. I hope you had fun going through the challenges. Congratulations to the top hackers. I really need to get around to removing myself from that list, actually. Top 5 are undefined is missing from the table. So that seems somewhat appropriate, doesn't it? Thank you very much, everyone.
Thank you so much, Stefan. Thank you for your exquisite style of demoing and sharing in life. So now, we're gonna move to taking a selfie with everyone. So please give a minute. While we are waiting for that, do you mind answering a question in the question and answer? So the question is, why is it not possible to unleash and hash password in Laravel password hashing method? And what are the security implications of attempting to do so?
So what was the start of the question?
The question was, why is it not possible to unhash passwords in Laravel's password hashing method?
Yeah, okay, so you're thinking of encryption. So encryption and hashing are two different things. They're both cryptography, but hashing is a one-way method, one-way algorithm. So hashing works by taking the value, passing it through the algorithm and producing the hash. And it is by design unhashable, undecryptable. And the point is that you can hash information and hash passwords, hash sensitive things, and by preventing you from decrypting them, it means you cannot access the source. You cannot work out what they were, but you can verify them. And so when you're hashing passwords to save them, you have the raw password and you hash it to store the hash in the database, and you don't have the raw password, and you cannot get the raw password without brute forcing it, which keeps the password secure. And then when you want to verify the password, you get the password again and you hash it, and you compare the two hashes. While encryption, you encrypt a value, then you can decrypt a value. And that's how encryption is designed. But hashing is designed to be one way only. And it's used for, you're protecting secrets like passwords. You want to compare a value, but you don't need the value, don't want to store the value. Or if you want to maybe sign a request and verify it hasn't been changed, because like the sign URLs that I mentioned that I had in there before, they use a one-way hash as well. And so you cannot turn that hash back into the original URL, but you can rehash the URL to verify the signature matches.
So I believe the time is running out. So thank you so much, Stefan, again.
That's okay. Thanks for having me.
Okay.